Okay, everybody, we're going to do a quick run through of the final exam, and I've pulled everything over to a Word document, and I've got that Word document available on the website, so you guys can go into the course documents and download it and try to work these out before you watch me work them out to see if you know what's going on. All right, so let's start with the first one. So if x equals 66 degrees, find the measures of angles 1, 2, and 3. Well, one of the things, so x is 66 degrees. We know that vertical angles, which are angles that are opposite of each other whenever two lines cross, are equal. So we know this is also 66 degrees. That's angle 2. Additionally, we know that supplementary angles, or supplemental angles, so that would be two angles that add up to 180 degrees. We can use that information to find the angles 1 and 3 by doing 180 degrees minus the 66 degrees, and we're going to get 114. So if angle 1 is 114 degrees, we also know angle 3 has to be 114 degrees because it is a vertical angle. All right, so for number 2, because geometric figures consist of sets of points, we can apply set operations to obtain the union, U, or the intersection, with the intersection sign, of such figures. The union of two geometric figures is a set of points that belongs to either of the figures or both the figures. The intersection of two geometric figures is a set of points common to both. So use the lines shown to find the indicated set of points. For these, I think it's easiest to draw actually on the, or just below the line. So we have line segment AB. So line segment AB. And then we also have ray BC. So starting at B and going forever to C. And we're looking for where they intersect or what they share. The only thing they share is this point right here. The only thing they share is point B. All right, for 3, a 15-foot ladder is placed against a vertical wall of a building with the bottom of the ladder standing on level ground 8 feet from the base of the building. How high up will the wall does the ladder reach? Well, first thing, let's go ahead and draw a picture. So we're talking about right angles. We have a 15-foot ladder that's leaning up against a wall, and it tells us that it is 8 feet away. So 8 feet away. Hopefully you recognize this is a right triangle, and we're going to use the Pythagorean theorem. So a squared plus b squared equals c squared. And a squared and b squared. A and b are legs, or the shorter sides of the right triangle, and c is the hypotenuse, or the longest side of the right triangle. So it doesn't matter. The 8 is a leg. It can be a or b. I'm going to choose to substitute it in for a. So 8 squared plus b squared equals 15 squared. So 64 plus b squared equals 225. Subtract the 64 from both sides. We get b squared equals 161. Now the trick is to make sure you go ahead and take the square root. So we're going to take the square root of both sides. So we get just b equals the square root of 161, which is about 12.69. All right, for number 4, it just wants us to find the perimeter of a rectangle. It's even been nice enough to draw it for us. If you happen to remember that twice the length plus twice the width equals perimeter, you can use that formula, or we can just add up going all the way around. So, because perimeter just means the distance around something. So 15 centimeters plus 5 centimeters plus this 15 centimeters plus 5 more centimeters. And our answer is going to be 40 centimeters. For number 5, to find the area of the triangle, we've got to remember that for a triangle, area equals 1/2 base times height. So for this, we've got to figure out what the base and the height are. So the base is down here, it's the 25 inches. So 1/2 times the 25 inches. And the height is whenever you drop straight down and form a right angle to the base. So that's going to be 4 inches. And whenever we work that out, we're going to have the 25 times 4, which is 100, and then we need half of that. So we end up with 50, and then inches times inches is inches squared, or 50 square inches. All right, number 6 is a little bit more interesting. So we need to find the area of the shaded region in terms of pi. First, we need to find the area of the whole circle. So we need the big circle minus the 2 little circles. And that's going to give us the shaded region. You need to remember that the area of a circle, area equals pi r squared. So pi r squared, r being the radius. And the radius is just from the center of the circle out to the end. Well, it's a little bit tricky, but not too bad. We need to find the radius of the big circle. Because we know that this is 3 centimeters, we know if we go the other direction in the same circle, that's going to be another 3 centimeters. So the 3 and 3 gives us 6, and that's going to be the radius of the big circle. So the radius for the big circle will be 6, and the radius for the little circles is 3. So the area of the big circle is going to be pi, and then plug in the r of 6 squared. So there's for our big circle, so the area of the big circle. So 36 pi. And the area of the little circle is going to be pi, and then the r for that one is 3, so 3 squared, or 9 pi. And if we use what we wrote up here, that the big circle, that we take the area of the big circle minus 2 of the little circles, then we will be doing 36 pi. So 36 pi minus 2 of those little circles. So that's 36 pi minus 18 pi, which is just 18 pi. All right, for 7, we're going to find volume. And so it's the volume, and we need to look at this as 2 different shapes. So it would be like a silo maybe. But it is a cylinder in this lower portion. So this is our cylinder. And then it's also half of a sphere. So up here, we have half of a sphere, which a sphere is just a ball. So we need to find the volume of the whole object. It's 1/2 of the sphere plus cylinder, or can shape. So we need to know the formula for both. So the area of a sphere is going to be 4/3 pi r cubed, and the area of the cylinder is going to be pi r squared times h, so that's just the circle on the bottom times the height. All right, so with that information, we can actually go ahead and find the area of the sphere. So 4/3 pi, and then the r, this isn't too tricky, but it's a little bit. It tells us that from one edge to the other is 16 feet. So half of that is going to be 8. And so if the radius is 8 on the bottom, the radius is also going to be 8 on the top. So the radius of 8, and then cubed. And whenever we work that out, we're going to end up getting 2,048 over 3 pi. So So there's the area of the whole sphere. Again, remember, we're going to take half of that in a minute. And then let's do the area of the cylinder. So pi, then our r is still 8 squared times height. Our height is 21 feet. And if we work that out, we're going to get 1,344 pi. Because again, we're keeping it in terms of pi for the first answer. And then we put this together, so we're going to take half of the sphere, so 1/2 times that 2,048 over 3 pi, plus the area of the cylinder, so the 1,344 pi, and that's going to give us 5,056 thirds pi. So there's one of the answers at once, where we're giving an exact answer using pi. And then if we want to give a decimal approximation, and a little squiggly equal sign just means about or approximately, we'll get 5,295 cubic feet, or feet cubed. All right, for number 8, a stock can go up, down, or stay unchanged. How many possibilities are there if you own 5 stocks? Well, each stock has 3 options. So this one's short, so I'm going to actually draw it out. 1, 2, 3, 4. So this represents our 5 stocks, and there's 3 options for each one. So we're multiplying all those, or it's the number of options you have to the power of how many stocks there are. So 3 to the 5th power, which is 243. Okay, and then for number 9, there are 5 performers who will present their comedy acts this weekend at a comedy club. How many different ways are there to schedule their appearances? Well, we have 5 of them, so there's going to be, so there will be 5 people coming on. For the first person that comes on, since no one's been on stage, there are 5 options. For the next person that comes on, because one person's already been on, there are 4 options, and then 3 options, and 2 options, and whoever's left is the last one. So that's the same as 5 factorial, but we can just look at it as the 5 times 4 times 3 times 2. And when we multiply that out, we get 120. Okay, and for 10 can be a calculator problem if you just want to enter it in with the factorial button, which is the little exclamation point, factorial. Or we can actually work it out, and it's not too bad by hand. So 25 factorial means 25 times 24 times 23 times 23 times 22, and so on, all the way down to 1. So 25 times 24 times 23 times, and then I'm going to stop for just a second, times 22, but all the way down to 22, 21, 20, etc. Well, that's the same as 22 factorial. So we write that over. The 22 factorial, we can cancel. So it just equals the 25 times 24 times 23, which is 13,800. All right, for number 11, we're trying to figure out if this is a permutation or combination. How many different 3-letter passwords can be formed using the following letters if no repetition of letters is involved or is allowed? So the order matters. If the order matters, it's a permutation. So again, that's because the order matters. Okay, for number 12, we've got Tyrone, Maria, Kim, Ian, Simone, Sergio, Jim, and Eduardo. And they've been invited to a dinner party. We're trying to figure out how many ways, for A, how many ways can they arrive? So again, this is very similar to the comedians coming on stage. We have 8 people. The first person that arrives, there's 8 options. The next person that arrives, there's 7 options, and 6, and 5, and so on and so forth. So really it's just the same as 8 factorial, which is 4,320 ways they can arrive. For B, How many ways can Tyrone arrive first and Eduardo last? Well, we still have these 8 people, but we know that Tyrone is first and Eduardo is last. Well, if 2 people are, we know that when these 2 people are arriving, then we have 6 people left. So we have 6 options, 5 options, 4, 3, 2, and then 1 option. That's the same as just a 6 factorial, or 720. And then for C, find the probability that Tyrone will arrive first and Eduardo last. So to find the probability of that, we're going to take how many ways Tyrone and Eduardo can arrive in that order. So we have 720 out of the total number of possibilities. So the 4,320, and that reduces down to 1 over 56. For 13, you're dealt 1 card from a 52-card deck. Find the probability that you are not dealt a 4. There's a couple ways to do this one. I'm going to look at this as 1 minus the probability that you are dealt a 4. So the probability of something not happening, so the probability of not a 4, is the same as 1 minus the probability of a 4. So with a 52-card deck, there are 4 suits, so that means there's going to be 4 4s in the deck. So this will be 1 minus, and then to find the probability of drawing a 4, there are 4 cards in the 4 4s in the 52-card deck. So 4 out of 52, and that's going to end up giving us and reducing down to 12 over 13. So the probability that we are not dealt a 4 is 12 out of 13. All right, for number 14, you randomly select 1 card from a 52-card deck. Find the probability of selecting the 4 of clubs or the king of hearts. So they're being very specific. They want 1 of 2 cards. So there's 2 cards that we're after out of a total of 52 cards. So there's the probability, and we're going to reduce that down to 1 over 26. So remember to reduce when you can. All right, for number 15, 1 card is randomly selected from a deck of cards. Find the odds against drawing a black ace. Well, one of the things, so we've switched to odds and no longer probability. So we need to know that the odds against something, I'm going to call it, we'll say against E, that's how your book references it, is the probability of it not being the E over the probability of it being E. So in our instance, this is the probability of not a black ace over the probability of drawing a black ace. Well, there are 2 black aces in the deck. So the probability of drawing a black ace is going to be 2 out of 52. And the probability of not drawing a black ace is going to be 50 out of 52. And whenever we reduce all that down, we end up getting 50 over 2, which is 25 over 1. Or that can be written 25 to 1. All right, 16. 16 is a little bit tricky just because there's 1 extra part, but it's not too bad. So the number of discs shown are placed in a box, and 1 disc is selected at random. Find the probability of selecting a green disc given that the number selected is at least 4. So if we know that we drew a 4 or higher, then that means we did not draw this one, or this one. We know that right away. So we've narrowed it down to 5 of these discs. And we want to find the probability of drawing a green one. So there are 4 green discs out of those 5. So your probability is going to be 4 out of 5, or 4/5. For 17, too far, all right. A random sample of 30 college students is selected. Each student is asked how much time he or she spent on homework during the previous week. The following times and hours are obtained. So it wants us to construct a frequency distribution for the data. So to do that, we're going to go through and basically just count. So we want to find out how many 15s there are. So here's a 15, and there's a 15, and that's all I see. So 15s are used. And we're going to look for 16. So here's one, and here's one. So 3 of those. And then we're looking for 17s. And there are no 17s, so we'll put down a 0. And let's look for 18. So there's an 18, an 18, an 18, and one more. So 4 of those. For number, we're trying to find how many 19s there are. So 1, 2, 3, 3 19s. I'm just scratching these out so that it's quicker to find what's left. Looking for the number of 20s. So there's a 20, and here's a 20, and that's all I see. So just 2 of those. For the 21, let's see, 1, 2, 3 21s. For 22s, see 4 of those. And now it's getting a little quicker. So the 23s, just see 2 of those. The 24s, 4 of those. And for the 25, it's just the 2 that are left. So here and here. Oh, and then I see that I have 122 left. So where I did think I had 4, that actually means I have 5. So let's fix that. So actually there's 5 22s. I missed that one. You probably saw that before I did. But if you're marking out your data points that way, you're able to see if there's anything that you did skip. Okay, for 18, find the mean for the following group of data items. The mean is just going to be the average, like we're used to. Let's see if I can move that. So the mean is the average, like we typically think of, where we add up all the numbers and we divide by how many numbers there are. So 2 plus 5 plus 1 plus 9 plus 6 plus 7 plus another 9 plus 4, and there's 8 of those total, so all over 8. Then we add the top, we get 43 over 8, and that is 5.375. So the mean, or the average, the way we typically think of it, is the 5.375. Okay, and then for 19, it wants us to find the mean that we have a frequency table. So it's letting us know that the score of 1 happened 3 times, score of 2 happened 5 times, and so on and so forth. So actually, whenever we're trying to find the mean, to find the total, we have to do 3 times that 1, and we're going to add, there were 5 2s, so 5 times 2, plus, and then there were 2 of the 3s, because it happened twice, so 2 of the 3s, and 6 of the 4s, and 6 of the 5s, 2 6s, 1 7, and 2 8s. And then to figure out how many items there were in total, we're going to add all the numbers from the frequency. So, because there were 3 1s, there were 5 2s, 2 3s, 6 4s, 6 5s, 2 6s, 1 7, and 2 8s. So that's how many items there were in total. Whenever we crunch through that, we're going to get 108 over 27, and that reduces down to 4. Okay, for 20, we want to find the median. The median is actually pretty easy to find. The trickiest part, believe it or not, is just putting the numbers in order. So let's start with the lowest one and work our way up. So 32, then the next will be 37, then 40, then 44, then 53, and then 57. Now they're in order. The median is the middle number. The problem is that we have 6 numbers, so there's not a true middle number. When that happens, we find the average or the mean of the 2 middle numbers. So we have that 40 plus 44 over 2, and that gives us 42 for our median of that set of numbers. Okay, and then for 21, it wants us to find the mid-range. Well, remember, the mid-range is the lowest number plus the highest divided by 2. So the lowest value plus the highest value divided by 2. And we look through all of our numbers. The lowest is 1.1, and the highest is 6.8. And then we divide that by 2. So we got 7.9 over 2, which is 3.95. The instructions say to round to the nearest tenth. So this 5 makes the 9 go up. So we end up with 4.0 for our answer. For 22, find the range for the group of data items. The range is just going to be the highest minus the lowest. So the highest number we have is 24. The lowest number we have is 20. So the range is 4. For 23, the scores on a test are normally distributed with a mean of 50 and a standard deviation of 10. Find the score that is 2.5 standard deviations above the mean. So if they're normally distributed, we have a bell-shaped curve, and in the middle is 50. Now we go 1 standard deviation over, that's 10. We go so this would put us at 60. If we go another standard deviation, that's going to put us at 70. And then we only want to go half of a standard deviation, so we're going to go 2.5. So half of 10 will be 5. So we're going to actually end up at 75. Another way that we could have done that is we were simply doing 50, so the mean plus 2.5 times the standard deviation. And again, that gives us 75. All right, for 24, use the table below to find the percent of data items in a normal distribution that lie A first, below, and B above a z-score of 2. So let's go find our z-score of 2, which is right here. And underneath that, we see the 97.72. So in our normal distribution, the z-score is saying that of 2 is saying that there is 97.72% below the z-score of 2. So for A, our answer is going to be 97.72. And then for B, what's above that, we take 100%, subtract 97.72, and we get 2.28%. So there's our 2 answers. Okay, number 25. The table shows the number expressed in millions of citizens who moved in 2004, categorized by where they moved and whether they were an owner or a renter. Find the probability, expressed as a decimal round to the nearest hundredth, that a randomly selected citizen who moved in 2004 was a person who moved to a different country. So we're concerned to find out, we need the number of people that move to a different country out of the total number of people that move, so the total number of people in this chart. So move to different countries, just these two. So we have 0.3 and that 1.1. And then out of all people, we need to add up all 6 of those numbers. So 11.7 plus 18.7 plus 2.4 plus 4.6 plus 0.3 plus 1.1. And whenever we do that, we get 1.4 on top, 39.1 on bottom, and then we divide that out. We're going to get 0.035. It says around to the nearest hundredth. So rounding to the nearest hundredth, 5 makes the 3 go up, 0.04 for our answer. All right, for 26. For 26, 6 stand-up comics, A, B, C, D, E, and F, are to perform on a single evening at a comedy club. The order of performance is determined by random selection. Find the probability for A, that comic E performs second, B, comic D performs last, and C will perform fourth. C, the comedians will perform in the following order, and D, comic A or comic F will perform fourth. Okay, so in order to find the probability of that, first thing we have to do is find all possibilities. So the total number of options for these performers to perform, or the total number of orders. Because there's 6 of them, this is like before, we're thinking about 6 factorial. So all possibilities is 6 factorial, or 6 for the first, 5 for the second that goes on stage, 4 for the third, and so on and so forth, which is 720 for all possibilities. So for A, that comic E will perform second. Again, we have 6. If we know comic E is second, that leaves 5 for the first spot, 4 for the third, 3, 2, and 1. So that's the same as 5 factorial, which is 120. So the probability is going to be 120, or the total number of ways we can have comic E perform second, out of the total number of ways the comics can perform. So 120 over 720 reduces down to 1/6. For B, that comic D performs last. So comic D is last, and comic C is fourth, which means we've got 4 people left. So that's the same as 4 factorial, 4 times 3 times 2 times 1, which is 24. So that's going to be 24 out of the 720 possibilities, which reduces down to 1 out of 30. For C, the comedians perform in the following order. This is actually really easy. There's only one way to have that exact order. So that's just going to be 1 possibility out of the 720 total possibilities. And then for D, that comic A or comic F will perform fourth. So in the fourth position, there are 2 options. So in those 2 options, only one performs, obviously, which leaves us with 5 performers. So we've got 5, 4, 3, and then 2 and 1, with this first 2 being put there because that's either A or F. So there's 2 possibilities for this position. And then we work that out. We get 240. And again, we need to be thinking about that out of the total possibilities. So 240 out of 720 is going to give us 1/3 for our probability. Okay, For number 27, a group of students is asked to pick their favorite ice cream. The students are asked to rank the 3 flavors, chocolate, vanilla, and strawberry. The results of the ranking are as shown. How many students voted in the survey? Well, first off, if we come across, so we have 17 people that voted with their preference, their order preference being chocolate, vanilla, strawberry, 7 that voted chocolate, strawberry, vanilla, 2 that voted vanilla, chocolate, strawberry, and 1 that voted strawberry, vanilla, chocolate. So the number of votes, we just add those up. So we have 17 plus 7 plus 2 plus 1, which gives us 27. And then how many students selected their favorite ice cream in this order? So chocolate, strawberry, vanilla. Chocolate, strawberry, vanilla is right here. So 7. How many students selected vanilla as their favorite flavor? Well, in looking, this is the only column that has vanilla as their favorite flavor. So 2 students. And then how many students selected strawberry? Scroll down so you can see it. How many students selected strawberry as their favorite flavor? And if we look, strawberry being the favorite flavor only happened 1 time, so only 1 student. Okay, number 28. The homecoming committee members are voting on the theme of the year's homecoming festivities. The 50s, which they use F, the 70s, S, and the 80s, E. Their votes are summarized in the following preference table. Which theme is selected using the plurality method? Remember, the plurality method is just the choice that has the most first place votes. So we're looking at the 80s, the 70s, and the 50s. So we go through and we see that there's 12 that put in the first column, there's 12 that voted for the 80s first. And then the last column, we have 1 more vote that selected the 80s first. Then let's see how many students voted for the 70s. So we have the 70s being ranked first in those 2 columns, so 9 and 1. And then for the 50s, we have 10 and 5. So we ended up with 13, 10, and 15. So the 50s won if we use the plurality method.
I know, right? Let's put you on the spot like that.
Okay, for number 29, the homecoming committee members are voting on the theme of this year's homecoming festival. Oh, sorry, we just did that one. Oh, no, I'm sorry, same problem, but now we're going to use the board account method. So the board account method is where however many options there are, so in this case there's 3 options. That means that first place gets 3 points, second place gets 2 points, and third place is worth 1 point. So it's a ranking. So for us to go through and figure out how many points each got, we'll go through and pick out the 80s first. So the 80s, and again, remember, this is worth 3 points, 2 points, and 1 point for first, second, and third choice. So there are 11 students that wanted as their first option. So it'll be 11 times 3. And here we have 10 students that want it as their second, 8 students that have it as their third, 6 more students that want it, that want it as their third, so 6 times 1. 2 students that want it as their second option. And then 1 more student that has it as their first choice. And when we work that out, that gives us 74 points. For the 70s, we have 11 students that voted that as their third choice. That's worth 1 point. And there's 10 more that voted it as their third choice, so that's 1 point. And 8 students who really liked the idea, it was their first choice, so 3 points. 6 students who want it as their second choice are 2 points. 2 students who have it as their first choice are 3 points. And 1 student who has it as their second choice are 2 points. And when we add that up, that gives us 48 points. And let's do the 80s. Excuse me, let's do the 50s. So for the 50s, we have 11 students as their second choice, or 2 points for each of those votes. We have 10 students that have it as their first choice, or 3 points per vote. We have 8 students that have it as their second choice, or 2 points per vote. 6 more with it as their first choice, or 3 points per vote. Then 2 more as their third choice, or 1 point. And then 1 more student that voted as third choice, or just 1 point. And if we add all that up, we get 91. So using the board account method, we also will be choosing the 50s. Okay, for number 30, and make a little bit more space right quick. So number 30, the University Administration has asked a group of student leaders to vote on the aspects of college life to target for improvement over the next year. The choices were housing, library, theater, and fitness center. The votes are summarized in the preference table. So using the board account method, we need to figure out which one wins. Again, there's 4 options. So instead of the previous example was 3, since there's 4 options, first choice is worth 4 points, the second is worth 3, third choice is worth 2 points, and the fourth choice is worth 1 point. So let's look how many wanted the theater. For the theater, we've got 12 with first place, so those are worth 4 points apiece. 25 that have it as their second choice, or 3 points apiece. 4 that have it as their fourth choice, or 1 point per vote. 20 that have it as their third choice, or 2 points per vote. And 11 that have it as their first choice, so 4 points per vote. Then we add all that up, we'll get 211. And then let's look at library. So for the library, we've got 12 that voted it as second place, or 3 points per vote. 25 that voted it first, or 4 points per vote. 4 that voted it second, or 3 points per vote. 20 that voted it fourth place, or 1 point per vote. And 11 who voted it second, or 3 points per vote. And that gives us 204 points for the library. For housing, we have 12 that voted at third place, or 2 points. 25 more that voted at third, or 2 points per vote. 4 that voted at first, or 4 points per vote. 20 more that voted at first, or 4 points per vote. And 11 that voted at last, or 1 point per vote. And then we add all that up, we get 181. And then for our last one, let's look at a fitness center. So we have 12 that had it last place, or 1 point per vote, and then 25 more that had it last place, or 1 point per vote. 4 that had it third, or 2 points per vote. 20 that had it second, or 3 points per vote. And 11 that had it third, or 2 points per vote. And that gives us 127. So our winner is going to be a new theater. Okay, and let's look at 31 right quick. So for 31, a small country is comprised of 4 states, A, B, C, and D. The population of each state in thousands is given in the following table. According to the country's constitution, the Congress will have 29 seats divided among the 4 states according to their respective population. Use Hamilton's method to find each state's apportionment of congressional seats. Okay, there's a few things we need to remember. We first need to find the standard divisor. So the standard divisor is the total population divided by the number of allocated votes. So for us, the total population, they tell us, is 580. And again, that's in thousands. And the total votes, or the total number of seats, is going to be 29. So that's going to give us 20. And then we need to find the standard quota. And that is the population of a vote, the population of a group, divided by the standard divisor. All right, so let's go ahead and make a chart. So A, B, C, and D. So the standard quota is what we're going to do for this first row. So for A, we're taking 52 divided by 20. That's going to give us 2.6. For B, we take 104 divided by 20, and that gives us 5.2. For C, we're going to take the 196 divided by 20, and that's going to give us 9.8. And for D, the 228 divided by 20, that gives us 11.4. So, using Hamilton's method, we drop off the decimals. So we just put the whole number. So the original, the lower quota is going to be 2, 5, 9, and 11. Now, if we add this up, the problem is that that's only 27, which means we have 2 more votes, so we have to distribute amongst these 4. The way we do that, for the extra votes, we look and find the 2 highest decimal places. So we have a 0.8 and a 0.6. Those are higher than the 0.2 and 0.4, so those 2 votes are split equally. So we're going to add 1 to A and to C. If there had only been 1 extra vote, we just would have added it to C. So in total, we end up with 3 for A, 5 for B, 10 for C, and 11 for D. All right, and our last question in our review. And I'm going to shrink this down a little bit so we can hopefully get it all on there. A small country is comprised of 5 states, A, B, C, D, and E. The population of each state is given in the following table. Congress will have 56 seats divided among the 5 states according to their respective populations. Use Jefferson's method with D equal to 32,920 to apportion 56 seats. So first off, D is the modified divisor. And we're going to use the modified divisor, which will be given to you, to find the modified quota. The modified quota is the population divided by the modified divisor, or D. So for A, we're just taking that population, so 133,643, dividing by 32,920. And we divide that out, we get 4.06, and we're going to drop off the decimal. So just 4. For B, the population of 225,213, divide that by the D, or the modified divisor, of 32,920. That's going to give us 6.84. Drop off the decimal, so 6 seats for state B. For state C, 304,907 divided by the modified divisor, so the 32,920. That gives us 9.26. Drop off the decimal, so just 9 seats. For D, the 536,366 for the population, divide by D, or the 32,920. That's going to give us 16.29, which, again, just 16, so we're dropping off the decimal portion. And for state E, the 716,559 divided by 32,920. That gives us 21.77, or 21. And then let's double check that we did everything properly. To double check, we're just going to add up our numbers. So 4 plus 6 plus 9 plus 16 plus 21. And sure enough, whenever we add all those up, we get 56. So we know that we apportioned all the seats properly. Okay, good luck studying to everybody. And if you have any questions, send me an email.